Welcome everybody. I'm Ella van der Zande and I'm your math lecturer. The math modules for the fast track program consist of 3 modules. Math 1, which have logic and set theory, Math 2, linear algebra and languages, and Math 3, graph theory. So for all 3 modules we use the same book, Discrete Mathematics of Seymour and Lipschutz. And of course you can find the study guide on Teams and also some additional material, readers for linear algebra and also readers for the graph theory. All other material can be found in the book, but of course online you can find many exercises on these subjects. In Math 1 we'll talk about 2 subjects. We'll talk about the set theory, relations, and logic and propositional calculus. Okay, let's start with the set theory. Well, a set is a very simple thing. It's just a collection of objects, of symbols. If we look at the set, it can contain cars, it can contain stamps, it can contain people, and of course when we're doing math, it normally will contain symbols like letters, charts, numbers, etc. If we look at the notation of sets, then a set S would be a collection of elements, let's say A, B, C. So this is a very simple set with 3 objects in there, A, B, C. And you could also have a set with numbers or a combination of numbers and characters, or you could have a set of symbols with a combination of charts and numbers. So whatever you'd like to think of, you can do it. And if we look at one of these elements, let's call this first one as 1, then you can say A is an element of set 1. So this symbol means element of. And as you see that A is an element of S1 and of S2 and of S3. Well, if we look at the B, we can say that B is an element of S1. We could also see B is an element of S2, but B is not an element of S3. And you use the element of symbol to explain that it's not an element. If we look at the set, and it's different from real life. If you're a stamp collector, you can have more stamps, more equal stamps, so you can later trade them with other stamp collectors. But in a set in math, if you have 2 identical elements, they don't count twice. So for instance, if I look at this set, where we have 2 B's in there, then the number of elements in this set is 3. The number of elements in this set is 3. And so these 2 A's just count for 1. So doubles don't exist. Also, what you need to know, a set has no ordering. So whether I write the set A, B, C, it would be exactly the same as the set B, B, A, C, A. So repetition is not an issue, ordering is not an issue. If we look at this set, so we described it as a list of all elements in the previous slide. So we had S would be, for instance, 1, 3, 7. But you can also give a description. So for instance, another set, let's call this one 1 again, S2 would be all elements which are integers, and for instance also larger than 7. So then this set would be identical to 8, 9, 10, 11, etc. And the number of the element S1 would be 3, but the number of elements of S2 would be infinite, because there is no ending to this set. We also have some special sets. So for instance, if we look at U, that's normally denoted as the universal set. And so if we talk about exercises, if we talk about combinations of sets, then there's always some big all comprising set where we can take our objects from. And this U could be, of course, the all integer numbers, could be all characters, it could be all possible cars, whatever. And so you define the universal set as the collection where we can take our elements from. And if we look at another special set, that's this one, which we can also write like this. And if we look at the second notation, then you already think of, okay, it's a set with nothing. And indeed, this is called the empty set. So a set with no elements. So if we look at the elements from the universal set, then none of those elements are inside the given set, the empty set. If we look at more sets, then there is also a way of describing them with the help of a Venn diagram. So to give you an example, let's say we have set A containing of the numbers 1, 3, 7. And we have set B containing of the numbers 3, 8, 12. And let's say the universe is all natural numbers, n. Okay, then if we make a drawing, then we always draw the universe as a rectangle. And so this is supposed to be a rectangle. Never mind my lines, I can't draw straight lines. So this is U. So U is all positive integer numbers, set, natural numbers. Okay, then we have a set A, and this set A contains of 3 symbols. And we can draw them as a circle. So a Venn diagram consists of a rectangle, which represents the universe, and inside it has the sets we're talking about, in this case set A, and we also have set B, and now you already see that B has one element in common with A, so let's take another color. So this one would be B, with 3 also from A and 2 outside the set. And so now we've drawn a Venn diagram containing of a set A and a set B. They overlap, so there's one element in both of them, and the total rectangle is the universe where we take them from. So if we would like to draw some elements outside A and B, that would be 2, 4, 5, etc. All the elements from the natural numbers. We can also talk about subsets. So let's again draw a Venn diagram. Okay, so this is U again, and let's take U being the natural numbers again. So this is U. Then I could have a set A of containing 1, 4, 8, 9. So let's say this is A. Okay, then we could make a different set. Let's call it B. And B could contain, for instance, 8, 9. And then you will see that 8 and 9 also belong to A. So I could draw B inside the circle of A. And if that's the situation, then we call B a subset of A. And the notation would be B a subset of A. And you see me making this small line there underneath the strange sign. And that means that it could also be an identical one. So if we look at A, then A itself is also a subset of A. So they may be identical. If we omit this small line, then for instance B is a subset of A, then we call this a proper subset. And that means that there is minimal one element outside B which is in A. So they may not be identical. So this one means subset or the same, and without the line it means a subset, a proper one, a real one. So at least one element is outside B which is in A. If we look at subset, there are some special rules, some theorems. So if we look at this list, and the most of them are quite obvious. So of course, if A is a subset of B and B is a subset of A, then they're exactly the same. So if both are contained in the other one, then they must be the same set. And of course also the second one, if A, let's say this is A, is a subset of B, and this B is again a subset of C, then of course this subset A, this set A is a subset of C. And we already saw that A is a subset of itself, and of course because all objects come from the universe, then any set A must be a subset of this universal set. And the other thing also applies. If we have an empty set, there are no objects in there. So the empty set is always part of any other set, even the empty set itself. So the empty set itself is a subset of the empty set. And as we saw last time, if A is a subset of B and they're not identical, then we call it a proper subset. So then at least one element is inside B which is not in A. That is a proper subset. If we look at some other aspects of sets, we can also call two sets disjoint, and that means that they have no overlap. So if I have this universe U and I have a set A and I have a set B, and they don't overlap, so they don't have any elements in common, then we call them disjoint sets. Okay, thanks for watching this first video. I hope you enjoyed. On the Teams you can find a lot of exercises on sets with a lot of answers. And for the questions where there are no answers to, we'll make separate videos to help you with them as well. Hope you managed to make the exercises for the first part of the set theory, and looking forward to seeing you for the next video. If you have any questions, you can always contact me through Teams, through the regular hours which are scheduled on your Outlook agenda. Okay, see you until next time.